Welcome to today's deep dive. So picture this. You're standing in a massive sports bar.
Oh yeah, we've all been there.
Right, and you look up and see, like, 24 screens. They're all flawlessly synced, showing uncompressed 4K video, zero lag, and, absolutely no messy cables anywhere.
It is pretty magical when you actually stop and think about it.
It really is. And the secret behind that wall of glass, well, it's this $6,483 black box called the Blustream PRO48HBT70CS Custom Pro Matrix.
That is a mouthful of a name for sure.
Oh, definitely. But okay, let's unpack this. Why on earth does an AV router cost over $6,000? I mean, it basically just plugs TVs together,
Well,
right?
see, that's the thing, because it's not just a switcher. It's essentially a massive data compression engine and a power plant disguised as a matrix.
Wait, a power plant?
Yeah, exactly. We are talking about taking 4 incredibly heavy 4K HDR signals and pushing them out to 8 remote locations.
Over just standard CK cables, right?
Right, using HDBaseT technology, which is a
Yes.
huge deal.
Which is wild, actually, when you think about the raw physics of data transfer. I mean, a standard 4K HDMI cable struggles past, what, a few meters before the signal completely drops off a cliff?
Oh, absolutely. The data just dies.
Right. Yet this Blustream pushes that same heavy 4K HDR up to 40 meters and 1080p up to 70 meters.
And it injects power while doing it?
Yeah, the PPOC or power over cable thing. So the receivers behind the TVs don't even need to be plugged into the wall. But I have to ask, how does a basic copper C cat cable not just instantly choke on all that data?
What's fascinating here is the modulation mechanism, because HDBaseT doesn't just, jam raw HDMI signals down a wire.
That would be a total disaster.
Complete disaster. Instead, it uses this highly specific encoding technology called pulse amplitude modulation.
Okay, so how does that actually work?
So it takes the heavy video, the multi-channel audio, the bi-directional IR for your remotes, and the electrical power, and it mathematically interleaves all of that into these rapid-fire micropackets.
Oh, wow. So instead of that old analogy of trying to force 4 wide lanes of traffic down a tiny dirt road,
Exactly.
more like a high-speed bullet train, right?
Yeah.
Perfectly packing different types of cargo into standardized shipping containers before it even leaves the station.
That is a much better way to picture it, yeah. And it completely eliminates the need to run thick, fragile HDMI cords through commercial ceilings. But getting the data there, that really only solves half the problem.
Right, because dealing with the displays on the other end usually creates a whole new headache for installers.
Oh, it is a massive headache.
Yeah, looking at our HDTVSupply source material here, I see specs for color space conversion, or CSC, and independent downscaling. But hold on, doesn't a mixed AV setup fundamentally rely on the ED handshake?
Yep, normally it does.
Right, so if you introduce just one legacy 1080p monitor onto the network, doesn't the source usually panic? Like, it restricts the whole entire system to 1080p, totally wasting your shiny new 4K screens.
That is the lowest common denominator problem, yes.
So how does this matrix physically bypass that hard-coded hardware limit?
Well, it actively intercepts and breaks the chain. Rather than letting the source talk directly to the dumbest TV in the room, the matrix acts as a firewall.
Oh, so it sits right in the middle.
Exactly. It negotiates the maximum 4K resolution with the source itself, and then its internal scaler individually processes the output for each of the 8 discrete ports.
Meaning it's physically unpacking the 4K video, crunching it down to 1080p for the older screen, while leaving the 4K stream completely untouched for the newer displays.
Spot on. But it's not just scaling resolution, it is mathematically manipulating the color bandwidth itself.
Wait, really?
Yeah, and that is the CSC at work. See, true 4K 60 Hz at 4.4.4 color timing requires massive bandwidth. We're talking around 18 gigabits per second.
That is huge. And HDBaseT natively caps out at around 10.2 gigabits, right?
Exactly. So to fit that 18 gigabit signal down the pipe, the matrix uses color space conversion. It selectively compresses the color data down to 4.2.0 while keeping the 4K resolution and HDR totally intact.
Ah, I see. So the human eye still perceives a flawless 4K HDR image, but the underlying data footprint has been drastically slashed.
Right, so it actually survives the trip down the cable.
That is incredibly clever.
It really is. And if we connect this to the bigger picture, this is entirely about protecting commercial investments.
Because you don't want to just throw away perfectly good TVs.
Exactly. A business owner can upgrade a few screens to 4K today, keep their legacy 1080p displays running, and, never compromise the visual experience on their premium hardware.
So what does this all mean for you? Well, the next time you're sitting there watching perfectly synced feeds in a massive venue, you'll know it's not just cables making the magic happen.
Definitely not just cables.
Right. It's real-time algorithmic downscaling, power injection, and color space compression happening millions of times a second right there behind the drywall.
It is, and honestly, it leaves us with an interesting dilemma for the future.
Oh, how so?
Well, looking through the HDTVSupply menu, they're already heavily pushing new 8K HDMI products.
Oh boy, 8K. That's a whole different beast.
It is. As our displays push toward 8K, the data load becomes exponentially heavier.
Right.
So it makes you wonder, will our physical copper cables eventually hit an absolute brick wall of physics? Or will clever algorithmic compression like CSC keep the humble wire alive forever?